The VitaGoat serves as a principal vehicle for micro-enterprises while providing the local community or social institution with high-quality nutrition. Operating without the need for any electricity supply or generator, it uses locally available fuels. This is a critical feature due to the unreliable supply or high cost of electricity in most developing countries. The full system includes 4 major components. The cycle grinder shown here uses energy produced through a pedal-powered system that employs adjustable speed pulleys, permitting fast and easy grinding of a variety of foods. The operating capacity allows some foods to be produced at least 10 times faster than with traditional methods. The steam boiler operates on wood or other solid fuels or liquid gas. Steam-injected pressure cooking can be 10 times more fuel efficient than traditional open-fire cooking. Water is heated in an inner chamber, and the resulting steam is reheated in a tube, creating a superheated steam that is much hotter than regular steam. This is then fed into the cooker. The VitaGoat cooker is made from stainless steel. This vessel can pressure cook up to 15 liters of food per batch in 30 minutes or less. This greatly reduces cooking time and saves fuel. It is equipped with temperature and pressure gauges and a safety pressure relief valve. The filter press shown below the cooker is also made of stainless steel. It operates much like a traditional juice press. Here at Africare's pilot project in rural Mozambique, the VitaGoat system is shown being uncrated. The boiler, which is the heaviest component, comes in its own crate. The whole system can be unpacked and set up within 2 hours. The finished setup is shown in the production area, a room of about 10 square meters. The boiler has been connected to a rudimentary chimney. Preparations are now shown for soy milk production, including the insertion of the filter bag into the press. The boiler is shown being prepared by pumping water from a bucket or any water source. The sight glass shows when an appropriate amount of water has been pumped into the boiler. Then the fire is started in the firebox at the bottom of the boiler. Food preparation begins with the grinding of the soaked soybeans into a mash, which is later added to the cooker. Even the local policeman is getting into the act. Each soy milk batch is made from about 2 kilograms of dry soybeans, which have been soaked overnight or for half a day. After about 5 to 10 minutes of grinding, the soybean mash is ready to prepare for the cooker. It is added to about 12 liters of water before cooking. After the product is gradually added to the cooker, it is sealed and the steam injection begins, bringing the product to the cooking temperature and pressure desired. After about 20 minutes, the cooked slurry is released into the filter press. The soy milk begins to run out immediately. At this point, sugar, salt, or flavorings can be added. Now, Donna Rita, the leader of the micro-enterprise, is shown squeezing out the rest of the soy milk and separating it from the okara fiber, which is the nutritious pulp left behind. Yogurt is one of the easiest products to make from soy milk. This is done by simply adding bacterial culture, or in this case, existing yogurt, to the product and incubating it. Fresh soy milk is being sampled by people who've never had it before. This customer is clearly ready for seconds. The lightly sweetened soy milk is almost universally accepted. 3 kilograms of tofu are made from 1 soy milk batch. After pressing, blocks are cut, which are then further cured in a cool water bath. Here we see the installation of the fruit mill attachment to the cycle grinder. Fruits and vegetables, in this case tomatoes, are processed into juices, purees, soups, and other prepared products. After cooking the liquid and the pulp together, the product is released into the filter press. The cycle grinder can also be used for products such as peanut butter, shown here, which require no further cooking or processing. This also allows the cycle grinder to be used by itself in certain applications. The community of Dingaraya is home to about 30,000 people. There is no electrical supply in this remote location. These factors make it an ideal host for one or more VitaGoat systems. Each component is described and analyzed as it is set up in the system. Another high-value local product is made by processing shea nuts, or karité as they are called in French West Africa. The shea nut paste is further processed into skin creams and cosmetics, as well as for foods including chocolate. Traditionally, the shea nuts were ground in a back-breaking process of hand grinding, as this woman demonstrates. The process is made much easier with the cycle grinder. Peanut butter or paste is also a popular local product. In the community of Doba in Chad, a VitaGoat system is in full operation. When in season, and often in a glut of supply, mangoes are an ideal fruit for the production of value-added products such as purees or juice. The local community leaders, some of whom are investors in the VitaGoat project, gather to sample sour soy milk, yogurt, and tofu.
A Canadian-made system was set up as a model for the Indian technology transfer. Each component is carefully studied before the local prototype fabrication begins. The model system is demonstrated in operation with a batch of soy milk. These photos, taken later, show the first Made in India version only 3 months after the first demonstrations. The experience with this project proves that lower cost and high-quality VitaGoat systems can be available along with regional training and tech support. Since the end of 2005, when this technology transfer was successfully established, more than 20 VitaGoat systems have been shipped internationally.